Hello everyone, Mr. Schultz here. Welcome to Integrated 1. We're going to be doing lesson 4-3, which is slope-intercept form. So what is slope-intercept form? Slope-intercept form is going to be a linear equation that looks like this. Y is equal to mx plus b, where b is where it hits the wall. So this would be 0, b right here. I know it looks like a 6, so I'm going to make it a B. Now it looks like a ugly 8. Now the M is the slope, like how much up rise over run. So some examples of this would be like y equals 3x plus 2. That means it starts at 2 and it goes up 3 for every 1. Up 3 for every 1. The example of this would be 0, 2, xy. And then plus 3, 5 over 1. Plus 3, 8 over 1. Plus 3, 11 over 1. Now, that's one example. Another example could be y equals 2/5 x plus 4. And so it'd start at 0, 4, and then it'd go up 2 over 5. Up 2 over 5. All right, so write an equation. Example 1. Write a linear equation in slope-intercept form. Write an equation in slope-intercept form for the line that has a slope of 4/7 and a y-intercept of 5. Okay, well that's pretty simple. Y equals 4/7 x plus 5. So I know that the slope is equal to 4/7 and the y-intercept, the b, maybe we put a little tail on it, is equal to 0, 5. Done. Let's go on. Rewrite linear equations in slope-intercept form. So if we look at this right here, this example 2, it says negative 22x plus 8y is equal to 4. This is what we call standard form. So this is in standard form. Anytime that we can write an equation in this form, it's a linear equation. Another type of linear equation would be slope-intercept form, meaning make it look like this. So let's do it. What we're going to do is we're going to add 22x to both sides because the opposite of minus is add. So the opposite of negative 22x is add 22x. So I resolve this and I have 8y is equal to 22x plus 4. Well, now I have to get y by itself. I only want 1. So if there's 8 of them, it's 8 times y. I'm going to divide by 8 on both sides. Now at this point we get to the idea of, all right, do we need to simplify or not? So 22 divided by 8 is 22 divided by 8. And 4 divided by 8 is 1/2. Because 4/8 is 1/2. Now I'd probably want to simplify this. I'd probably divide by 2 on the top, divide by 2 on the bottom, but I would leave it like this because the slope would be 11/4. And it still hits at 0, 1/2. That means, like if this is 1 right here, it hits right here. And this is negative 1 right here. It hits at 0, 1/2, halfway in between 0 and 1. So here's our slope-intercept form, converted from standard form. Now, if you can write the equation in slope-intercept form, it is a linear equation. Now, some of you might be like, well, can't we write any equation like that? Not necessarily. For example, if I have y is equal to x squared, that can't be rewritten into y equals mx plus b, or that can't be written into ax plus by is equal to c form, standard form. This has what we call a quadratic. All right, let's go on. It shows us a parabolic shape. All right, write linear equations. Jobs. The number of job openings in the United States during a recent year increased by an average of 0.06 million per month. Okay, so I know that this right here is a rate. It's 0.06 mil per 1 month. So I know this is going to be our slope, rise over run. In May, there were about 4.61 million job openings. Write an equation in slope-intercept form to represent the number of job openings in the United States in the months since May. Well, how many months from May is May? 0. So we're going to say, hey, the start value is 4.61. 0, comma. And so we would write this out and say, hey, y is equal to, now technically, we could write it as 0.06x plus 4.61. But we have to be we have to explain it. So the slope 0.606 isn't 0.06. It's the growth, because that's what the slope is, the growth. The growth is 0.06 million per 1 month, and it starts at 4.61 million jobs. So there's going to be a lot of times where we're going to have to understand, what do these numbers mean? They're not just naked numbers where it's just hey, here's a 5, here's a 4, that's it. No, there's units of measurements we're not stating. All right, let's go on. Learn graphing linear functions in slope-intercept form. So if you have 2 parts, you're good to go. The only 2 parts you need are the following. You need to know the start value, and you need the slope or the growth. Now, you don't even need the start value. You just need one of the points. But it's really nice if you have the start value, also known as the intercept. That's where we come up with slope-intercept. So it says, example 4, graph linear equations in slope-intercept form. It says graph a linear equation with a slope of -3/2. So that I know right now that this is going to be a negative slope. It's going to go down like this. And it has a y-intercept of 4. So it's going to start at 0, 4. So I just need to go over here and plot it. And now, I don't even have to know which one's which. I just go like this. I understand, hey, it's one's going up, one's going right. So I can do this carefully. I'm going to go down 3 from 4 is now 1. I'm going to go to the right 2. I'm just going to keep doing this. Down 1, 2, 3 over 1, 2. Do it again. 1, 2, 1, 2, 3 over 2. Down 1, 2, 3 over 2. Now I can even go backwards. Up 3, 1, 2, 3, backwards 2. And now I can graph this with a line, like so. But I have to lift it correctly. So seeing this, this shows us our slope triangle. It goes down 3, to the right 2. And we know that our start value right here is 0, 4. So we really only need 2 things, a point and what's the growth like. All right, let's go on. Graph and linear functions. What about the intercepts? Intercepts are really nice. So for example, if we were going to plug in 0, like 0 for the x and 0 for the y, if I plugged in 0 for x, then I would get -3y equals 18. So I know that -6. So it's going to be 0, -6 right here. All right, well, what if we plugged in 0 for y? Then we're going to get 12x is equal to 18. And if I divide by 12 on both sides, I'm going to get 1.5. That's not so nice. So that's like right there, but I want to make sure I do this correctly. Well, let's see. Another way to do this, besides plotting the intercepts, is to convert to slope-intercept form. If we were to convert to slope-intercept form, that will tell us where our start is, and then what we have to do is we just have to figure out what is our growth. So looking at that, I can slowly start to figure out what is my slope-intercept equation. There we go. It starts at -6, correct, and it's going to go up 4, 1, 2, 3, 4 over 1. How do I know it's 4 over 1? Well, I have to make the slope into a fraction. Now, if it's not a fraction, just put it over 1, and now it's a fraction. 4 is the same thing as 4 divided by 1. So, up 4, 1, 2, 3, 4 over 1. And this does make sense, because this half, 1.5, would be in between. Up 1, 2, 3, 4 over 1. Up, and I can go backwards. All right, well, now I just need to graph it. I take this tool, or a straight edge if you're doing this in class, and I graph it like so. Let's go on. Graph constant functions. Well, it's not as if we haven't done this, so let's wait a second. So if we're graphing constant functions, like one, we should know what it should look like. It says y is 2. So no matter what, the y value is 2. So I should know that that's going to be like right here. But, we could figure out what this is. If we plugged in 0 for x, y has to be what? 2. What if we plugged in 4 for x? Y has to be 2. This literally says y equals 2. No matter what, y equals 2. All right, well, this should be a horizontal line. So let's draw it in like so. There we go. That's it. Now, if it's x equals 2, then that's going to be up and down. But that's not a function, because that would have inputs that have multiple outputs. All right, let's go on. So something that I like to go over is hey, there's a 4-step process to problem solving. Understand what the problem is talking about, come up with a plan, do it, and then check to see if it worked. See if it's reasonable, and go on. If it says, hey, you're going to bring 3.5 friends with you to the zoo, how did you bring 3.5 friends to the zoo? Does that make sense? I mean, you don't call a friend half a person, and if you bring half a person, the police might come up and have a talk with you. All right, let's go on. Shopping. The number of online shoppers in the United States can be modeled on the equation -5.88x plus 7 is equal to 172.3. All right, give me a second. All right, I see the error. There should be a y right there from the book. It's y. So -5.88x plus y is equal to 172.3, where y represents the number of millions of online shoppers in the United States, and x is the years after 2010. So if it's 2010, it's 0. Estimate the number of people shopping online in 2020. So we're talking about a 10-year period. So our domain, our x values, we would probably want to go 11 years. 0 to 11, because we want 10. So understand the problem. All right, well, we should probably come up with the equation, plug in our inputs. We probably want to graph it as well. Well, we probably want to graph a couple points, and then it says estimate, so maybe estimate using graphs. But we probably want to use the equation as well to see if we're right. All right, so here we go. Understand the problem. All right, well, they give us this. Devise a plan. Yeah, we're going to graph it, and then we're going to do it. All right, so let's do it. So I understand that if I can convert this into slope-intercept form. If I convert it, I would add 5.88x to both sides. And then I have this plus 172.3. Okay, well, let's do it. So I know at 172.3, it should be right about here. Now, I hate estimating using graphs because it's not going to be accurate. So I wouldn't want to do it, but we kind of have to. So what we're going to do is we're going to plug in the information and go from there. Like at the moment, these aren't nice, easily graphable numbers. So we'd probably have to just bite the bullet and do the work. So they want after 10 years. Basically, if we plugged in 10 for x, we're going to get an answer. We'd get 58.8 plus 172.3. Seeing this, it looks like the number of shoppers will be 231.1. So that's like right about, so 10 years right about here. So I'll tell you right now, as I critique this. 1, this is definitely a graphing calculator type of deal where we're going to have to use our calculator to figure it out. We're going to use the equation to figure it out. We didn't really need to use, or we shouldn't have used our graph to figure it out because we can't really read the graph that well. Like if you look in the book, it has this graph, but like we can't figure out what the answer is. So we would have to use the equation. That's just it. No ifs, ands, or maybes about it. Alright guys, so thank you for watching this. I'll catch you in class. You guys have a wonderful day. Bye.